Alright everyone, welcome back to the Advent of Code. Day 13. Yeah, hopefully we can get through all of the ones I want to do today. They should all be weekday problems, so hopefully they're not as bad as some of the other ones. I think they go quick and smooth. Of course, that's that's always the idea. Never is actually. But let's go. Day 13. Transparent origami. You reach another volcanically active part of the cave. It would be nice if you could do some kind of thermal imaging so you could tell ahead of time which caves are too hot to safely enter. Fortunately, the submarine seems to be equipped with a thermal camera. When you activate it, you're greeted with congratulations on your purchase. To activate this infrared thermal imaging camera system, please enter the code found on page 1 of the manual. Apparently the elves have never used this feature, so to your surprise, you manage to find the manual. As you go to open it, page 1 falls out. It's a large sheet of transparent paper. It's marked with random dots and includes instructions on how to fold it up. Your puzzle input, for example. Transparent paper. No, I think we got the idea. So here's our test input. 610, 014, 910, 03, 104, 411, 60, 612, 41, 013, 1012, 34, 30, 84, 110, 214, 810, 90. Okay. Put along y equals 7 and x equals 5. The first section is a list of dots on the transparent paper. 00 represents the top left coordinate. The first value x increases to the right. The second value y increases downward. So the coordinates 30 is to the right. Increases down. Okay. I feel like we've done something similar already. Maybe we can go steal some of that code. The coordinates in this example form the following pattern, where hash is a dot on the paper. A little backwards, isn't it? Dot is an empty, unmarked position. Then there is a list of fold instructions. Each instruction indicates a line on the transparent paper and wants you to fold the paper up. For horizontal y equals lines, or left or vertical x equals lines. Okay. In this example, the first fold instruction is fold along y equals 7, which designates the line formed by all of the positions where y is 7. In this example, the first fold instruction is fold along y equals 7, right here. Line formed by all y equals 7. So 1, 2, 3, 4, 5, 6, 7. Oh no, this one. 7 down. What? Okay. 7 down. Yeah, gotcha. I think they said that earlier. I'm mixing things up in my head. Okay. And these are marked with the dash, right? Because this is a horizontal line, fold the bottom half up. Some of the dots might end up overlapping after fold is complete, but dots will never appear exactly on a fold line. The results of doing this fold looks like... Wait, some of the dots might end up overlapping after the fold is complete, but dots will never appear exactly on a fold line. Okay. So we get rid of this line, and we put this on top of that. And then they now overlap. Interesting. The result of doing this fold looks like this. Now only 17 dots are visible. Notice, for example, the 2 dots in the bottom left corner before the transparent paper is folded. Yeah, these ones? Right. Now they're up here. These dots appear in the top left corner. 0, 0? Oh wait, no, these two. I meant these two. Close enough. Because the paper is transparent, the dot just below them is a result at 03. Remains visible as it can be seen through the transparent paper. Also notice that some dots can end up overlapping. In this case, the dots merge together and become a single dot. The fold instruction is fold along x equals y, which indicates this line. So 0, 1, 2, 3, 4, and on 5. Because this vertical line, fold to the left. What happens if it's not like directly in the center? Or what if this side is bigger than this side? Do we ever come across that problem? I feel like we might. I feel like we might. Okay. So we can fold, yep. And then we end up with the square. Instructions make a square. The transparent paper is pretty big. So for now, focus on just completing the first fold. After the first fold in the example above, 17 dots are visible. Dots that end up overlapping after the fold is complete count as a single dot. How many dots are visible after completing just the fold instruction on your transparent paper? Okay, I have a few ideas on how to do this. So we're pretty much always keeping this like top and left side, top left side, right? So that would be, we're starting from the 0 position and working our way out. Then we can end up splitting. So yeah, I'm thinking of using like an array. We end up splitting it down here, and then whatever. So we're gonna end up with 2 arrays. This original one with this half, and this one, this half. But then what we do is we invert this array up. So was it y? I guess this is 15 or something. Becomes y0, and then y0 becomes y7 or something. And that depends on which side it's folded on. So if it's folded along the x-axis, then x, what's this, x11 becomes x0, and x6 becomes x5, right? And then what we do is we end up comparing if it would be OR, right? The OR operator. So this is true, and this is not true, which is false. Then that would end up being true. And same thing for this one and this one. So not true, not true, or not true, true. And then if they're both true, we get a true. If it's false, we get false. That should be simple enough, I think. Now how big do we want this paper? So what was I was thinking, oh, we need to account for how big the paper is, right? Like whatever side's bigger, we would have to shift each one of them over that much. Oh, that's gonna be, man, that's gonna be a lot, isn't it? Okay, well, let's first get our instructions. So this is our test input. Then let's get our actual inputs. Quick, cover your eyes. That's our real input. Okay, we have, how many folds is this? 10? 11? Something like that. Maybe 12. And we have a ton of dots. So what I might do is, let's see. We might go through all of them and see how big the paper should be. Just like one of the previous days. I might be able to steal some of that code. Okay, let's first delimit these. So it's going to be, we have to take off the last 2 elements in this. Okay, so how do we do that? I'm thinking, what's it? Input array. Input array and dot pop, and then we do -2. Maybe that'll work. Does that give us the instruction we want? Right? Put along y equals 13, and our input is this. Oh, wait. Oh, yeah. I guess we keep going until we get to this. So we're gonna do line by line. Okay, that should be easy, I think. So, what's it? Dots equal... We're just gonna have an array, and then we're gonna have a list of folds. Folds equals array. So for x in inputs array, we're gonna do if our line, well, if our line's not empty, basically. There's a few ways we can do this. If f dot, where was it? X dot, we can do strip. That'll make like that empty line, or it'll take off all the space at the end of the line. So since this only has a new line, then this would be empty, and it would also take off these. That's good. Maybe we should do x clean. I don't know. X clean equals x dot strip, right? And if x clean is equal to just a null string or an empty string, not null, equals, then we well, we skip that line, and then all the rest should be instructions now. Maybe not. Wait, is there... What would be an easier way? I guess fold along would probably be easier, huh? Okay. So we're just gonna have a case for if x clean is, well, one of these. I guess starts with this would probably be the best. Dot starts with, and then we put our string in here. Fold along. Starts with fold along, then we know that it's a fold instruction. If it's empty, then we don't do anything. And then elif, and then our last one would be the else, which would just be, oops, this, our dot positions. Dots position. I'd actually rather do it like this, or labeling. Put it right before empty line. We don't actually have to put anything in here. Just pass. And then here, okay, we want to parse our fold instructions. X equals x equals 655. I think we just add that, yeah? So what we're gonna do is we're gonna take off this front part. I think we can do this. X clean. We can do this, and then was it foot along that length? Or is it length? Let's start with length. Yep. And then let's see if that works, right? Now here we're gonna pass just so that it compiles, or at least runs. I don't think there's compiling. Okay. So, yep, that's perfect. We could also hard code it if we want. This probably makes more sense instead of trying to look up the length every time. Yeah, we'll just leave it. make it easier to read. Let's see, empty line. So yeah, we can pass that, and then everything else. We're going to... I keep turning on to the other tab. Let's see if we can do this. Okay, we want to split these, right? Actually, we want to add these to the folds. So, folds, not Control F. Folds, dot append, xClean. We might want to split that by the equal sign. I don't know if I want to do it in this one line. It's starting to get a little complicated. What's it? Fold string equals this. And then what we're going to do is folds.append. And then we're going to do fold string dot split. We're going to split along our equals right here. So the first index is going to be what we fold upon, and then the second would be the location. I don't need another folder, thank you. And then I think that should work. Let's print folds. That works. I don't want to use tuples, actually. Can I do that? I don't think that works. Oh, wait. I just didn't include the... Okay, no, that's not gonna work. There's a way to do it. Just escaping me at the moment. It's fine. Basically the same thing. At least in our purpose. The only difference is this one's mutable. Okay. So now we want the dot position, and then we want to add those to our dots. So if now we just want to split them. xClean. I don't even know why I'm stripping it. Hey, welcome, yokoso. xClean dot split, and then we want to split upon, I think, commas, right? And then we just want to append that to dots. Now let's print our dots. Hopefully that works as we wanted to. This object is not callable. Oh, dot append. That looks right. I have no idea if that's right. I think it's this one, right? Let's go to our top. Yep, that looks good to me. Oh, actually, we should make these integers. So, okay. So, axis, comma, position? Sure, that should work. F position. Okay. And that should be our split. And what we're going to do is x. Yeah, now we can do tuples. Axis and then int F position. And that should give us an int for that side. Actually, that's kind of kind of nutty. Kind of works in Python, but I don't think that's good practice. Mixing, was it characters and ints together? It'll be fine, right? Okay, now here we want to do pretty much the same thing. It'll be x position, y position equals xClean. That's what I don't even know why I'm using xClean, to be honest. It's okay. And then we want to do int x position, int y position. And let's make this a tuple, shall we? Hey, Vivex, thank you for following. Oh, did I run? It's clear. There we go. They're all tuples and they're all ints. Perfect. Okay. Now, making the array might be a little bit more difficult. I was thinking we should make like a... So what are you working on? Oh, this is the Advent of Code challenge. This is day 13, part 1. Yeah, I feel like we should do the dynamic array thing where we look for the highest value so that we know how big to make the array, and then we will make the array afterwards. So let's see, we're gonna find the largest value on x and y. Or just x equals 0, or just y equals 0. And then we're gonna loop through them. Or just, okay, for position in dots, we'll do that. Okay, if position 0 is greater than largest x, then we want to update largest x with that position. And same thing for position 1, largest y. Oh, largest x. Can't forget that. Position 1. And that should give us what we want, hopefully. So let's clear that. I don't think we need to print these anymore. Okay, cool. Yeah, I don't know how we're gonna do the folding. This is gonna be interesting. Actually, let's put in our new file, our test inputs. 10 to 14. Okay. Just so that we have a smaller subset to work with. Make sure this all works as intended. Y7, X5. Yeah, that seems right to me. Okay, now we want to do... well, we just want to make the array. Yeah, array. Or let's... I guess we should do map. Heat map, maybe? Wait, I think that's the idea we're going for. We want... heat map, yeah? Sure, okay. Equals... it'll be 0. Actually, let's do... I guess false, yeah? False. And then X for... wait, I forgot to do this. For X in range... this is not going to do what I think it's going to do, I think. Well, let's do largest X. And of course we want to print our heat map. Heat. Actually, I think zeros will work. Zeros are a little bit more visually friendly, I think. So what do we have? We should have 10 of these across. I just do it again. I think it's... no, this one would be our X times X, and then this one would be Y for in range of largest Y. Right? Hold on. No. Python's so weird. The way you make arrays. I forgot how you do this. Something like... Do I just do it twice? I guess that will work. I think that works. Okay. So our Y would be 14 of these. Right? And our X would be 14 across. Oh, 10 across, 14 down. Yep, okay. Yeah, I just want to make sure that's it's all working correctly. It should be. Length of heat map should be 14. Okay. And heat map 0 would be 10. Right, alright. Okay, now we want to put in the dots. So for dots, in dots. Let's get rid of this. Find map size. Okay. Our largest map size, I guess. Oops, find... Yeah, map size. That should be fine. Heat map. Make map. Add dots. Parse inputs. Okay. So let's see. For dot in dots, it would be heat map dot 0, and then dot 1 would equal to 1. And then let's print out our heat map. For a row in heat map. Print row. Oops. List assignment index out of range. I'm currently working on a Python import visualizer. Huh. That's cool. How's it work? Let's see. Okay, what am I missing? Dot list assignment index out of range. Hold on, let's see. Dot heat map. Print dot 610. Oh, it's plus 1. Largest X plus 1, yeah. Largest Y plus 1. We also have to include that number. Wait, okay, what's wrong now? Printed dot heat map dot 0 dot 1 equals 1. Creates a function that gets run when Python tries to import something. It just throws the data in a graph, and you import something, and then the graph, and make the graph nicer and save it. Let's run. Interesting. I'm just trying to figure out how you visualize it. Sounds pretty cool. Definitely something I wouldn't have thought of. See, so yeah, we're not gonna comment this. What are we gonna do here? What is happening? I'm sorry, what? That is from the import request. If it's a link, I can't see it. You can DM me it though. Yeah, sorry about that. Okay, wait. Okay, what am I missing here? Let's see. What is y plus 1? Just make sure this heat map's working. So 1, 2. Let's see. Oh, I see. That's cool. Like it shows everything. Yeah, I'm definitely sure someone will find some use out of that. So, let's see. 0, 1, 2. Oh, what am I missing? For y in range of largest y. There are different moments. Let me get the lowest level of info. Dot 0. Dot 1. Okay, what part's failing? I think it's just this. Yeah. List assignment index out of range. Which index? Ah. Or is it the wrong way around? I don't think it is. Oh, it is. Well then, It's a little awkward. Maybe we reverse this. It's funny how we solved one problem that we weren't even looking for. And then let's do 0, 1. Kind of backwards, but it should work the same. Same thing without submit modules. Yeah, no, some people would definitely find that useful. That's yeah. Keep going at it. Doing good. I wouldn't even do this. Wait, so X is this way, Y is this way. We want to print it, print our map. Let's make a function for that. Define print map. Oh, no, that's not how you do it. Print map, and then our map, and then for X in how would we? I've done this before. You just print it sideways. Range of, what's it, map 0. Oh, length of map 0. Print. Hold on. What can I think right now? We want to go along the y-axis, and then we print this. So for X in range of length of map. Or Y, I guess. No, this one's Y. Wait, what? Let's just use I and J. It'll get too confusing. Let's see. We print map I J. Might be the other way around. Ji. Yeah, I have no idea. Let's just see if that works. And we're gonna remove the end character. And oh, wait a second. Yeah, no, this should be fine. End is nothing, and then after each one, we're gonna print end equals, or just print a new line. Oh man, I still gotta do days 12 and 13. Just finished 18. Taking a look at 19. Yeah, what was it? 12 was a little bit of a headache. Actually, what was 12? I don't remember anymore. Let's see. 12. Oh, actually, that wasn't too bad. I stopped after day 2. That's okay. It's not for everyone. But I really like doing puzzles. Programming puzzles too. Sort of a combination of well, a bunch of things I like. Okay, let's see if our print function worked. I'm not convinced it does. Print map. And then map. Heat map. Yep, that is not right. Ji, maybe? Does that look like what we have here? Oh yeah, okay. No, it's working. Cool, okay. Surprised that worked first, well, second time, I guess. Alright then, now we want to fold. I'm not sure how this is gonna work, but... Okay, we're gonna have like a split function array. Like, or a split array function. Yeah, I think I said that the wrong way around. So splits along x, split x. And then we're gonna do the x. I'm not gonna worry too much about like even sizes just yet. We'll make it work first. So we're going to split x, and then we're gonna do a split map y. Just like that. Right, so what we want to do, make an array of the left side, and we make an array of the right side. So for what's it, left map equals I think there's a way to do this. One line, maybe? It'll be I think for the Y one, it'd actually be easier. Wait, hold on. X. X's? Wait, is X downward? Hold on, did I do this backwards? You can do anything in one line, one expression even. No evil. Just trying to make sure it makes sense to do it in one line. Not just some like expression to spawn the devil. I made a one-line snake game once. Oh god. Okay, fold along. Wait, let's see. The first section, they fold Y. Y is downward, right? Y is this way. And for our Y, it's the second number. Actually, no, the X should be easier, no? Oh, here's the... Oh, God. Oh, no. What is this written in? Actually, that's, yeah, that's Python, isn't it? Globals, set items, set variable lambda. Yep. Oh, God. Okay, I think we can actually just do this. Split map. X equals X. Wait, no. Maybe column or column in X. Well, we need the map too. X map. Map if X. If column is less than X. And we do the same thing for the right side. Oh, this one would be backwards though. This might not make sense to do in one line. No, we just need to invert them, really. Well, let's just see if that that works. So print map X or left map, and then our right map, and then split map X. Our X would be what X did they use? They used 5, yes? Okay. 5, and then heat map. Let's see if that works. Yeah, indentation error. Alright. Pass. Oh. Oh, I see. Oh, column dots. Oh, okay. Yeah, no, that's not gonna work. Alright then. So let's see. 4. Enumerate might help. Would it? No, I'd rather just do the for loop. I think it should be fine. Let's see. So for column in map, my column, my X and Y's are kind of inverted the way I'm doing it. This is kind of interesting. So column in map, we're going to do we're going to do column in range of map. Length of map. I guess enumerate could work too. Here. If column is less than our X, then we want to add it to the left map. So left map dot append. Actually, how about we do this instead? Range of X. So left map dot append. Map column. And then then for the right side, for column in range, we're gonna go backwards. So map +1. No. Wait. Length of map -1 be x and then -1. That seems right. If column is... Actually, we don't even need this anymore. So right map